Okay, this is the basketball free fall example problem from week 4. So let's take a look at what it says. A basketball dropped from rest 1 meter above the floor, rebounds to a height of 0.67 meters. Assume the ball is not moving horizontally. Okay, calculate its velocity just before it hit the floor on the way down, just after it left the floor on the way up. Okay, and then if the ball is in contact with the floor for 0.1 seconds, determine its acceleration on the way down while in contact with the floor and on the way up. All right, so the first thing we want to do is start with a picture. Okay, so this is going to be 1 meter. All right, and then the ball sort of squishes and then comes back up to 0.67 meters. All right. And we need to set a direction as positive. That's super important when you start. And I'm going to just go ahead and say down as positive. Okay, you can set it either way. You just need to be consistent. Okay, and you need to mark it on the picture so me or the AP readers or any other student reading your work can follow along. Okay, all right. So the first thing that you want to recognize is, one, that this is a free fall problem. Okay, it's an object just moving freely under the influence of gravity and nothing else is really happening. And also that there are 3 parts to this, okay? So part 1 is on the way down. Part 2 is on the floor. And then part 3 is on the way up, all right? So you can use the kinematics equations for each part separately, right? But it's 3 different things happening, right? Because the acceleration is not constant compared when it's in the air versus on the floor. All right, so let's just go ahead and write down what we know. Okay, so for part 1, I'm going to have a V naught and a VF. Okay, so my V naught is 0 because it says it's dropped. All right, that means the velocity is 0. It's not thrown. It's just simply released. Okay, and then the VF is what we're trying to find at this point. All right, I know the displacement, and I'm going to go ahead and call that delta Y since we're working in the vertical direction. And that's going to be a positive 1 meter, all right, because I've set down as positive. That's important, okay? And then the secret thing that we know is the acceleration is going to be, I'm just going to use 10 meters per second squared while it's in free fall, all right? And that's also positive because I've said down is the positive direction, okay? All right, so this one, when you look at your kinematics equation, you'll see this is an easy one to use. That's 0. It's already isolated for VF. How convenient. Okay, so VF is going to be 10 meters per second squared times 1 meter. Oh, that's not even the right equation. God, I did that last time too. I was like, that's not the answer I got last time. Too early to do this. Okay, sorry about that. See, then you'll see how I'm making a mistake. Okay. Model mistake making. All right, that's the equation that I want to use. I don't know what I was thinking there. Okay. I don't know the time, right? So I can't pick that one that I was doing, which I realized when I got to plug in the T and then there was no T. All right, so we have to use this one. Okay, so that's that. Still conveniently isolated for VF. Yeah, because I already worked this problem once, but it didn't record, so that's why I already knew what the answer was. Okay, radical of 20, which is, I'm going to get my better calculator out. Okay, which is like, it was 4 point something, I can't remember. Let's see. 20 radical, 4.5, I'll just round it. That's more sense. Okay. All right, so it's very important, obviously, like I just demonstrated, you have to pick the right equation, right? Pick the one for what you know. Okay, let's move along. Okay, so let me just go to part 2 and then see. So now when I'm in part 2, my V naught is the same as this VF, and then this VF out of the floor is the same as this one's V naught, right? Because you're moving to the next version of it. Okay, so my V naught entering the floor is positive 4.5 meters per second. Okay, we don't know the final. We don't know the acceleration here. We don't know the time. We don't know how far it like compresses. So we actually really don't know very much about part 2. Right? So that's okay as you start to write that. I can't find anything about this, okay? So I'm just going to move on, all right? And I also notice in part 1, it just says after it left the floor on the way up, so that could be this one's VF, or that could be this one's V naught, okay? Because, right, that's the same thing happening, just depends on what part you're looking at. Okay, so I don't have enough information in part 2, so let's move on to part 3, okay? So the ball leaves the ground, And then at the top of its path, once it gets to 0.67 meters, it's going to have a velocity of 0. Okay, that's another secret thing that you need to just sort of pay attention to and know. When it gets to the top of the path, obviously, it's not going any higher, so that's it. So that's where it's going to momentarily go through a velocity of 0. Okay, the displacement is 0.67 meters. All right, but this time it's in the upward direction. Okay, and I've set down as positive, so I need to make sure that I put negative 0.67 meters. All right, the acceleration, it's still positive 10 meters per second, right? Because the Earth is still pulling things downward. Just because the ball started going a different direction, the Earth hasn't changed what it does, right? And it's accelerating things at 10 meters per second squared. All right, so I'm going to actually use the right equation this time. And I almost did it again. All right, it's exactly the same as last time, but now this one's 0. Okay, so then I'm going to move the, let's see, how do I want to do this? What am I solving for? V naught? Okay, so I'm going to move this to the other side. Okay, I'm going to take the square root of that. Oh, I forgot to mention something else over there. Okay, and I'm going to get negative 2, positive 10, and negative 0.67. Okay, and notice, do you see why this needs to be negative? Because if not, you have a negative under the radical, and that's not cutting it. All right, okay, so 2 times 10 times 0.67 is 13.4. Okay, radical is 3.7. Okay, now, how do I know what direction that is, right? Because when you take the square root of something, and I should have actually done that over here too, all right, it's a plus or minus. So you need to pay attention to what the direction is and set what it's going to be, okay? So over here in part 1, all right, it should have come out to be a positive because it was coming into the floor or downward, okay? So I would have chosen the positive side of the plus or minus. Okay, but here, this is also plus or minus. The V naught is going to be up, right, because as it leaves the floor. So I need to kind of pre-know that that one is negative. Okay, all right. So now we're on to second part. Okay, if the ball is in contact with the floor for 0.1 seconds, so I can add that to this. Okay, what's its acceleration on the way down, while in contact with the floor, and on the way up? All right, so in contact with the floor, on the way down and the way up, we already knew the acceleration. It's the acceleration due to gravity because it's in free fall. Okay, so that's like a non-question. They like to ask you little tricky questions like this. What's the acceleration when the ball's at the top? What's the acceleration when it's on the way up? It's always 10 because it's gravity. Okay, all right, so that's already done. Okay, so this one, now I can do this. And now I know this VF is negative 3.7, right? Because that's this one as it leaves the floor, and that becomes the initial for the way up. Okay, so now I can use my apparently favorite equation that I keep trying to use. And then I'm going to switch it around. Okay, negative 3.7 minus 4.5 over the time, which is 0.1. And I can't remember what it was, 3.6 and, 3.7 and 4.5 divided by 0.1, ooh, 82. Negative 82 meters per second squared. Okay, and that's a pretty big acceleration, but you have to think it's that ball is turning around very, very quickly. Okay, and notice that it's negative, right? Because as the ball comes into the floor, right, if I want to slow it down, the acceleration is going to have to work opposite that. Okay, and then the acceleration is still pointing upward as the ball then accelerates out of the floor to get faster. All right, okay, so that's that. I hope it recorded this time, because if not, I'm going to cry.